Okay, so the first thing I want to tell you before I show you the way we did another type of factoring is that to tell you that when the a value in front of x squared is negative, we're going to factor it out. Okay, and so what does that mean? So let's look at this first one here. I didn't leave myself a lot of room. This one here. So what I'm going to do is, what that means is I'm going to do the reverse of the distributive property, and I'm going to take out a -1, and that's going to change the signs of everything that's left inside. So I'm going to have an x squared minus x minus 20. Okay, and so now I'm going to look at this quadratic inside here, and I'm going to factor it the way that we just learned. I'm going to make a cross. I'm going to put up a -20 up here and a -1 down here. So I'm guessing that it must be -5 and +4 that multiply to -20 and add to -1. So now I know that this quadratic fully factored has a -1 in front, which is multiplying, times x minus 5 times x plus 4. Okay, so we're going to keep that negative rule in mind when we're factoring. Okay, so the next way that we learned to factor last week was when we do have something other than a 1 leading the quadratic. So we have ax squared plus bx plus c. So in this case, we're going to factor 4x squared plus 9m plus 5. Okay, so let me get a different color here. Let me go back to red. Okay, so I'm going to do like I did with my other type of factoring. I'm going to start with the cross. Now, remember when we learned how to factor and use the cross, I said this was a times c up here. So I'm actually going to have more now to multiply. I have a 4 times a 5. So a times c, now this value here is 20. And the b value still goes down at the bottom of the cross, and I'm going to put a 9. So obviously values that multiply to 20 and that add to 9 are 4 and 5. Okay, but we're not finished right now. So because x plus 4 times x plus 5 will not multiply back to this quadratic. Somehow we have to get a 4x squared to lead the quadratic. So what I'm going to do is I'm going to go back to using a box. We used a box when we multiplied polynomials together. So now I'm going to do the box in reverse, a little crooked. Okay, so in this area of the box, in the first quadrant, I'm actually going to put ax squared, right? And in this case, and down here, I'm going to put the c value. So ax squared in this case is 4x squared, and I'm going to put the 5 here. Now, what I'm going to put in these two diagonal boxes are the 4 and the 5, but they're going, oh, I used two letters here. I'm sorry, 4x and 9m squared. Let me erase that and fix it. That's an x. So there we go. So now what I'm going to do, instead of writing 9x, I'm going to represent the 9x by 4x and 5x that I found in the cross, these two values here. Okay, so I'm going to use the cross in reverse. I'm going to look horizontally at 4x squared and 5x, and I'm going to say, what's the greatest common factor of these two terms? Well, in this case, it's only x. And then I go horizontally, so I went this way, right? Then I go horizontally down across the bottom, and I say, what factors out of 4x and 5 that they have in common? Well, they have nothing in common, so I'm just going to put the number 1. Well, actually, they don't have anything other than 1 in common. Okay, now I'm going to do it vertically this way, and I'm going to look at these two boxes, 4x squared and 4x, and they have a greatest common factor of 4x. And I'll do the same thing with the next two boxes and look at the 5x and the 5, and they have a greatest common factor of 5. And so now what we have is x plus 1 times 4x plus 5. So is this the correct factorization? Well, let's multiply it out. Okay, so x times 4x gives me 4x squared. Outsides give me plus 5x. Insides give me plus 4x. And the last give me 5. And if I simplify the two like terms, I get 4x squared plus 9x plus 5. And so we are correct. So the factorization of this, the answer you would give would be x plus 1 times 4x plus 5. Okay, now I want to show you another example, and I'm going to have to do this by erasing everything for just a minute. So, see, erase all this. Let's take a look at another example. There we go. Now we have some space to do another one. Okay, so let's take a look at, like on my stylus, there it is. Let's take a look at one with a negative value. So I have 6y squared minus 5y minus 4. So I make my cross. I multiply 6 times negative 4, and I get a negative 24. And in the bottom, I put my b value, the negative 5. Okay, so I think of numbers that multiply to negative 24 and add to negative 5, and I realize it's negative 8 and 3. So now I'm going to make my box. Make my box down here. In this corner, I'm going to put the 6y squared. In this corner, the negative 4. And then the negative 8 and the 3, they go into these two boxes, and we add a y to them, 3y. Okay, so now I'm going to factor this. I'm going to say, what's the greatest, going this way horizontally, what's the greatest common factor between 6y squared and 3y? That would be a 3y. Now I look across, and I see negative 8 and negative 4. Now, given this rule, when a is negative, we're going to factor out a negative first. We're going to do that here too in our box. So given that the highest power of y is the negative 8y, has the coefficient of negative 8, instead of taking out a 4, factoring out a 4, we're going to factor out a negative 4. Okay? And now we're going to go vertically, and the greatest common factor between 6y squared and negative 8y would be 2y. And between negative 3y and negative 4 would just be positive 1. So hopefully we have gotten the correct factorization. It would be 3y minus 4 times 2y plus 1. I'm going to check it one more time just to make sure I factored correctly. So if I do first, I get 6y squared. Outsides give me 3y. Insides give me negative 8y. And the last give me a negative 4. Simplifying, I get 6y squared minus 5y minus 4. Okay, so these two methods are what we worked on last week in class. Tomorrow we will start looking at applications that will apply to these two methods. I hope this has been helpful. If you have learned how to do this another way, these two types of quadratics, and you're always successful, then I would suggest you use the way that you have learned. But this is what we learned in class, and we're finding it pretty quick and easy. So good luck on this, and best wishes.